Good morning and welcome to NASA's Jet Propulsion Laboratory in Pasadena, California. I'm Veronica McGregor of the Digital News and Media Office. Just 21 hours ago, the Perseverance rover made a picture-perfect landing in Mars, and at that time, the entry, descent, and landing team turned over the reins to the surface operations team. We have members of both teams here with us this morning to give us the latest update on the rover. We'll hear the current status and what the next steps are in this new era of exploration. For media on the phone line, please hit *1 to get into the queue to ask a question. And to ask a question by social media, please use hashtag #CountdownToMars. We have 1 hour for this news briefing today, and we will get to as many questions as possible. Now let me introduce our panelists for this news briefing. Joining us is Adam Stelzner. He's the Chief Engineer for the Mars 2020 mission. Aaron Stahura, the Deputy Phase Lead for Entry, Descent, and Landing. Pauline Huang, the Deputy Phase Lead, the Mars 2020 Strategic Mission Manager. Hallie Gangle-Abarca, the Imaging and Data Processing Team Lead for Surface Operations. And Katie Stack Morgan, the Deputy Project Scientist. And we will begin with Adam.
Thank you, Veronica. The team is overwhelmed with excitement and joy to have successfully landed another rover on the surface of Mars. This rover is an epic effort. It represents 8 years of hundreds of engineers at the laboratory, thousands around the world, a total of over 4,000 human years of investment. When we do such investments, we do them for humanity, and we do them as a gesture of our humanity. When I think back on our human space exploration, I am brought to remember the images that bring us as humans into that process. The first of which is the iconic image of Buzz Aldrin taken by Neil Armstrong on the Sea of Tranquility on July 20th of 1969. We were there with Buzz on the moon in that image. The next is Saturn, seen from Voyager 1 spacecraft, looking back at the planet after the first encounter. As a youth, this image brought to life the experience of space exploration. Another one from the 90s, the beautiful Pillars of Creation, taken by the Hubble Space Telescope, the image released April 1st of 1995. How many people were brought into the act of exploring space by these fantastic, iconic images? Well, we can only hope in our efforts to engineer spacecraft and explore our solar system that we might be able to someday contribute yet another iconic image to this collection. And I'm happy to say that I'm hopeful that today we can with this. This is an image of the rover Perseverance slung beneath the descent stage, its propulsion backpack, as it is being lowered to the surface of Mars. You can see the dust kicked up by the rover's engines. We're probably about 2 meters or so above the surface of Mars. We're still checking the timing of this image. It's just hot off the press. You can see the mechanical bridles that hold the rover underneath the descent stage. There's 3 straight lines heading down to the top deck. And then the curly electrical umbilical that is taking all of the electrical signals from the descent stage down to the computer inside the belly of the rover. In fact, the ones and zeros that represent this image will travel down that umbilical before it is cut and the rover is left safe on the surface of Mars. So there are these fantastic images that we've had a chance to take and are still getting down from the surface, taken by a set of EDL cameras, taken by other spacecraft. And we will hopefully be able to see them in the days coming. But some more of those beautiful images are going to be shared with you today, the ones we have in hand, and I turn it over to Deputy Phase Lead Aaron Stohura to talk about some EDL imagery.
Thanks, Adam. As Adam said, an immense amount of time and effort went into gathering each of those images that you saw. Of course, the final one was gathered yesterday as we were nearly finished with our entry, descent, and landing down to the surface of Mars. Another image that was captured midway through our journey down to the surface is what you're seeing on your screen right now. This image was acquired by the Mars Reconnaissance Orbiter, or MRO, one of our orbiters that's orbiting around Mars. You can see here in the zoomed in part of the image in the upper right, our spacecraft with a fully inflated parachute and hanging underneath it our protective entry capsule. Like Adam said with the descent stage, the descent stage downlook image, we're still figuring out the exact timing of when this image was taken as well. So it's even possible that we had already come out of the protective entry capsule and we're coming down on rockets to the surface, but we haven't quite analyzed this enough to figure that out. If you look just below to the little circle that you see on the screen, this was our eventual touchdown point. You can see it's near the delta that we've talked about that's so interesting to the scientists, and we'll get some updates on that coming up here. But just to give you an idea of all of the things that had to go correctly for us to make it to this point, at the point that that image was acquired, we had already undergone entry into the Martian atmosphere right on time, traveling at 5.3 kilometers per second. We already had undergone the searing heat of entry and pulled somewhere around 11 Gs of force as we decelerated quickly while entering the atmosphere. And we had steered our path through the atmosphere of Mars using thrusters and lift from our vehicle so that we could zero in on our eventual target here in Jezero Crater. So speaking of our target in Jezero Crater, I have another image to share with folks, if we could put that up. This was an image captured by our rear hazard avoidance camera. So this is looking backwards from the Perseverance rover's perspective. When I look at this image, first of all, I feel a great sense of relief. And second of all, I see a landing site that looks relatively safe, free of boulders, free of cliffs, free of great slopes. And that's what we spent a lot of time and effort, making sure that we identified those spots on Mars so that we could safely set the rover down in what we considered the best possible spot. One of the other things that is possible that we could get here is as we continue to get more higher resolution imagery down. This is just a thumbnail that we're looking at. We might even be able to see bits of the delta in the distance. It's possible, although yet we're not sure, if we captured the descent stage, our rocket-powered jetpack, perhaps even impacting the ground. We'll look forward to that and see if we, get some more data coming down in the coming hours and days. But in the meantime, we can check in on the status of the rover and see how it's doing. And for that, we have Pauline.
Thank you, Aaron. Yeah, so I'm going to talk to how the rover's been doing on Mars. I'm happy to say that the rover is doing great and is healthy on the surface of Mars and continues to be highly functional and awesome, and just I'm exhilarated. So currently it is 1 p.m. on Mars, for those that don't think in Mars time like the surface team does. Power system is nominal, including our comm systems are nominal. Yesterday we had 3 highly successful UHF relay passes where we sent data via our 3 different Mars orbiters, via Odyssey, Tracegas Orbiter, and MRO, and we got some excellent data that we're about to show you from those. Also, all that data relayed through our deep space network and all came down. So we got more rover engineering data and imagery, which we're about to talk to. We also processed and sent some more EDL camera images, which is going to be a preview, something fun for the future. We successfully fired our pyros on the rover. So a lot of the rover hardware is actually essentially bolted down on some level for safety reasons. And then once we land successfully on Mars, we actually start to undo those fastens. So let's see. So the first thing we did was we did fire our high gain antenna free. So that way, this is what we use to communicate with the DSN. And this is one of the ways that the rover will receive commands from Earth. And then we also fired our hazard avoidance camera covers. And so you're going to see there's the back side and the front side cameras. And you're going to see one of the images of the covers now deployed. And a beautiful image that we're going to show you in a minute. And then also there are a couple of other ones related to our robotic arm that we have fired. We haven't actually moved any of those mechanisms. We just released them. So, and the next step after that is, and the one other thing I was going to mention about communication system is that we did successfully command into our low gain antenna, which is this one right here, just because this one, the high gain antenna has not been successfully tested yet. And actually, I think right now on Mars, we are now getting data to see if our high gain antenna is green and nominal. But yeah, we were successfully able to send commands through our low gain, and the rover's doing well. And for the next coming days, and the other thing I was going to mention is that EDL landed us in a very flat, safe surface. So we're only at 1 degree tilt. So that's super flat for the rover, which is great. And we're actually if you look at the image of our landing site where our dot is, do you mind bringing that image up? Yeah, so if you see the landing spot, the rover's actually, the backside of the rover is pointing southeast, while the front is pointing, sorry, did I just say that right? The front of the rover is facing southeast, while the back is facing north. So when you look at the hazard camera data that we're about to show you, the back of the rover is actually looking toward the delta area, and the front is actually looking downward. So just to give you guys a little idea of the orientation of the rover at landing. And so I'm just going to move on to talk about what we're going to do for the next coming days over the weekend. So now that we've landed, we're going to do a series of hardware checkouts just to make sure everything's functioning and is doing well. And so we're going to do all of our instrument alignment checks on all of the rover. We're also going to do a helicopter checkout, which is at the bottom of the rover. We are going to proceed with our mast deploy, which is which has our mast instruments and cameras. So once that is successfully deployed, which will be on Saturday, we will proceed by taking lots of images with our mast camera, including we're going to do a deck panorama of the rover, and we're also going to do a full panorama of our landscape around us. It will take a little while to downlink all of that image data, but we do anticipating getting a lot of it over the weekend, just given the throughput through our orbiter assets. So we do think we're going to get a lot of good image data, assuming everything stays as nominal and per plan, down by Monday. So a lot of that data is going to be taken on Saturday, and we'll get it all on Sunday, and we'll see how all that goes. And then after that, we're going to prepare to upgrade the rover's flight software. So we actually landed on the cruise EDL flight software, as we call it. And now we're going to upgrade to the latest flight software for the surface team to use. And so that will be the next thing we do, is starting to prepare for that flight software transition. And once we get into surface flight software, we'll be fully ready to begin the next set of checkouts and upgrades with the robotic arm and other events on the rover. So a lot of exciting stuff. Okay, I'm going to hand it over to Hallie now, and she's going to talk to the really cool images we received last night. So,
thank you, Pauline. So as was mentioned, yesterday we received our very first set of instrument data products. So what we've received so far is our front and rear hazard camera images. So the front has cams, as you can see in this image from when the vehicle was in ATLO. In the very front of the rover, we have the 4 cameras, which are our front hazard cameras. So as Pauline had mentioned, when we landed yesterday, we had the cover still on these cameras. So if we take a look at the first touchdown image that we received, can we pull up the... So the first front HazCam image that we received with the cover on, it was still a black and white image, and it looked a lot like what Curiosity looked like when we landed. Low resolution, black and white imagery. Over the next few hours, after we deployed the cover, we were able to actually get down the full resolution color imagery. So this is a picture of with the covers still on. And then if we go to the next one, now we have our somewhat lower resolution, but really high resolution compared to what we've seen before on other previous missions, and now in color. So this is our first color front HazCam image and our first color image from the surface of Mars. This is not a color-corrected product yet, so we'll be continuing to work. Our team has been working up until 5 o'clock this morning, and we'll continue to be working hours like this over the weekend to get data as quickly and accessible out to the public. So this is an incredible achievement, and there's one other image I want to show. So one of the amazing things about these cameras is they're actually, as I mentioned, they are 20 megapixel color cameras, and we can actually basically take a small subset of that image and receive that. So what this image is of the wheel on the surface of Mars. It's the front right wheel, and we have now actually seen what it looks like right underneath the wheels. We have imagery like this that we will be releasing to the Raw Images website probably later today. Our team is just actively working on processing that data and getting that ready. One of the amazing things is now that we have this image data is we can now hand this over to the robotic and science teams, so that way we can actually begin to really start the mission. And to talk about the science on this mission, we have Katie Stack.
Thanks, Hallie. So to say that the Perseverance science team is excited for this rover to be safely on Mars is an understatement. We've been waiting years for this moment, and we're finally here. And so we found out just minutes after we heard that the rover was safely on Mars where our landing site was, and that was really incredible. And so here we are. We found out we're about 2 kilometers from the Delta. But you know what? The science team was ready. One of the activities that we did for years before arriving here on the surface of Mars was to prepare a geologic map of the surface of Mars where we thought we were going to land. So you can see that here. So what you were looking at previously was a picture of a base map put together from images from the HiRISE camera that's orbiting Mars. And so what we did as scientists, we mapped out the geologic units present in this landing site, and that's what you can see these different colors mean. And so between us and the Delta, we have a lot of interesting science to do. And so if you can we'll zoom into the area where we landed. We can go to the next image. Yes, so here we are. We landed in an area that the science team informally calls Canyon de Chelly, after the national monument in Arizona, and we'll name all of our rock targets on the surface of Mars after targets in this area. And what we can see here is that in true JPL EDL fashion, the engineers got us right on a very interesting geological contact. And so what we see here is we have the green unit, which we call the fractured unit, and that's based on textures that we see in these images from orbit. And we have where we landed, which is on these tan units, which are fractured and rough as we see them in the orbiter images. And we landed, thanks to TRN, on a smoother area shown in that dark tan. And so one of the first things that we as scientists are interested to know and to talk about is what these rocks really mean. And we've been looking at these orbiter images for years now, but now we've got images from the surface of Mars, so we can start making those connections between what we think we see from orbit and what we thought we've seen from orbit to what we're now seeing on the ground. So if we go to the next image, we'll see again these fantastic color images from the engineering cameras. And this is one of the first views we have on the surface. And while this area didn't have a lot of rocks, and the engineers were thankful for that, for a safe landing, we have enough for the scientists to really sink their teeth into. And one of the things that the scientists have first started to think about when we look at images like this is what the rocks are made of and what they look like. And so we're picking out different colors and tones and textures to try to figure out what these rocks might represent and what depositional process might have put these rocks on the surface of Mars. If we go to the next image, this is a close-up, and this is a really interesting image from a geological perspective. So what we see there by the edge of the wheel is a rock, and one of the first things we noticed was that it has a lot of holes or vugs in it. And there are a number of different geological processes that can make holes in a rock like that. And so the science team is now thinking about what this might mean, and one of the questions we'll ask first is whether these rocks represent a volcanic or sedimentary origin. And both of those would be equally exciting to the team, so we can't wait to find out. So we'll be looking forward in the coming weeks and months as our instruments get checked out to look closer at these rocks to help inform our plans for the future and what we're going to learn on the surface with Perseverance. So we can't wait to get this science mission started. And with that, I'll hand things back over to Veronica.
All right, thank you, Katie. All right, we're going to go to the phone lines now with questions, and the first person up is Bill Harwood with CBS. Go ahead.
Oh, thanks, Veronica. Can you hear me?
Yes, we can. Go ahead.
Just making sure. Yeah, I had a question for Pauline, if I can. First of all, the pictures are fantastic, so really great to see those. But Pauline, yesterday we were told about the software upgrade you guys have planned. Can you give us a little more detail on that? When does it start? How do you make sure that's safe? And I mean, you know, when I do stuff like that on my home computer, I'm always scared it's not going to boot up when I get done. How do you ensure the safety of it, and what does that new software package bring you for the surface mission? Thanks.
Sure. Yeah, so I'll just add that we actually did this exact same thing on our MSL rover that landed, 7 years ago. And so we actually did a very similar process, and we had a lot of heritage on how we did this. So we landed with the cruise EDL flight software because that's what the EDL team needed to land the rover. And so it's always been kind of part of our baseline plan to then transition to our surface flight software, which gives us all the capability we need to fully operate our rover. And we actually do this in over a four stall period. So we actually take it very slowly and deliberately. One of the first things we do is we just check. We have two computers on the rover, our prime and our backup computer. And so we actually do a checkout of the backup computer before we do the full upgrade first, and we also do some checks on the software, all that. And then we go ahead, and the first thing we do, and I should add that the surface flight software is already on the rover. It's been sitting there and it's ready to go. So it's a matter of just kind of switching the pointer, as you say it, like you kind of move your computer to no longer look at this software. Now let's go look at this one instead. So what we're going to do is we're going to temporarily point the rover to the surface flight software, and we call it a toe dip sol. And we're just going to actually toe dip, and we're going to do a series of things on that toe dip. We're actually going to just do a column checkout, just confirm everything's good. And then because we only can command the rover once a day, all of this is pre-sequenced, and we have it all on the shelf ready to go. So the rover is already going to then automatically switch back its pointer to the cruise flight software, and then go back to the state that we know of as today, that we know is all good. And then the team will then analyze the data, make sure that everything went well in the surface flight software, and then we'll go ahead and give what we call the go no go to officially transition to surface flight software. So we actually do a very set of deliberate steps to get to that part. And then once we do it on our prime computer, then we have a couple of sols to do it on our backup computer and a series of go, no-go events to do that. So that's why it takes about 4 sols to do that.
Okay, I'm going to read out a question from social media. This comes from Pablo on Twitter. This is a question we get a lot, so it would be great to hear the answer to this. Why aren't all the cameras on the rover color? Why do you still take black and white pictures?
I'll jump on this one a little bit. So a lot of our cameras on this vehicle actually are color for the first time. One of the reasons, though, that you do want to have black and white versus color is we actually bring this data down. When we downlink this data, it actually is for the most part black and white or color JPEG. So when we are bringing this data down, we actually have to, conserve data volume. So if we have black and white data, typically some cameras are just, that's a better format for it, but it actually allows us to bring down higher quality data. Now that we have better cameras and better equipment, now we can actually bring down color images from this rover, and almost all of the cameras on this vehicle actually will be color.
All right, thanks. We're going to go to the phone line next to Marcia Dunn with the Associated Press.
Yes, hi. How many pictures have you gotten back so far since descent entry? And of that, how many were of descent and how many are surface? And I'm wondering what any audio back from the mics coming in. And lastly, as you were seeing this picture of the rover being descended on the bottom of the crane, tell me what the reaction was like when that picture was seen by the team. Thank you.
Well, I can jump on certainly the last part of that question right away. So we're still getting the data down from the cameras that were taking pictures during entry, descent, and landing. So we don't have all of that quite yet. We're going to be getting it here over the weekend, and we'll hopefully have some more high-resolution images and potentially video ready to go for Monday. So we're all chomping at the bit, and I can definitely say that when we saw this image, I think we can flash it again, but seeing the rover hanging underneath the sky crane, underneath our rocket-powered jetpack, I mean, this is something that we've never seen before. It was stunning, and the team was awestruck, and there was just a feeling of victory that we were able to capture these and share it with the world.
And I'll just add, I don't know if Hallie has any more data, but for how many pictures we've received so far, I don't think we have those at our fingertips, but we could definitely find that for you guys. I can just say that we have gotten a number of what we call the thumbnail images. So we have gotten more than I can count, right? So I was just scrolling through all of the imagery we've gotten so far and that we're processing through, and it's higher number than I can say on my hands. So that's why we can't give you an exact number right now, but we can definitely get you that data going forward if you guys would like that. And I could just say that inside the surface MSA, when we first saw this image, it was exhilarating. The team went wild. I mean, we were just, actually the 2 images, I would say. We saw this image, and then we also saw the post-cover deploy image, and both images the team just went crazy for. The science team immediately started looking at all those rocks and zooming in and going, what is that? It couldn't have been better. We were just kind of like on cloud 9, and all of us were just saying we were kind of in this weird dream-like state. We're like, we can't actually believe that this is what we're seeing like right now at this moment, and that the image from EDL, I mean, just the clarity and just the reality of it, I mean, it was just unbelievable, and kudos to our imaging science, Justin Mackey, for getting these images up into the MSA for all of us to just like gaze in awe at last night. So it was pretty amazing.
And I'd like to add, as a scientist, we're used to the engineers showing us animations of the rover, and that's at first what I thought this was, and then I did a double take and said that's the actual rover. And just to think that the last time I saw the rover like this, it was in the high bay at JPL, is just incredible. And I can't believe that I'm now seeing the rover on its way to the surface of Mars. And the science team, Pauline wasn't kidding. As soon as we got that color image from the surface of Mars, our chat just lit up with the science team saying, look over here and look over here. And that's exactly what we were hoping for. And we can't believe that we're really doing science now on the surface of Mars.
Okay, we're going to take another question from the phone line. Mike Wall of space.com. Go ahead.
Thank you all. Just to follow up on that previous question, do you guys have any indication yet whether the EDL mic worked, and if you did get audio to accompany those amazing photos? And if you don't know that yet, when do you expect to actually get confirmation that you were able to capture audio? Thank you.
So we don't know that quite yet, and I would hope, if things go well, sometime over this weekend, we may get an indication of whether we have that audio, and maybe get it down late this weekend, early next week.
Great, thanks.
Okay, next, Eric Berger of Ars Technica.
Hi, congratulations everyone on such an amazing landing yesterday. I'm wondering if someone could talk about how this landing went with respect to Curiosity. Did you learn anything important? Were there any key differences besides the terrain navigation? And was there anything off nominal when you looked at the data, such as you've gotten so far about the landing, that in retrospect maybe scared you, or maybe not? Maybe everything went perfect. Thank you.
Eric, I'll take that one. You might recall that in Curiosity's landing, it all went beautifully. A couple weeks later, we were able to dig deep into the details and see a couple of things that were surprising. So I don't want to suggest that there may not be things that are surprising in Perseverance landing, but certainly last night went as smoothly as we could have wanted it to go. And, TRN taking us to a almost pool table flat landing site with rocks small compared to the size of the rover's wheels is exactly what we were hoping for. So the day went very, very well. We will, as we always do, comb with a fine-tooth comb through the detail and look for any anomalies that might teach us how to do our jobs better in the future. But we didn't see any huge ones that stuck out yesterday.
All right, next we'll go to Sarah Kaplan with Washington Post.
Congratulations. I was hoping that Katie could talk about, sorry, I have feedback from my computer. I was hoping that Katie could talk about, what we think this landing site is, these rocks are, those fractured units, what might they represent, and where in Mars history is the rover right now, geologically speaking?
Yes, absolutely. So Perseverance landed on the crater floor of Jezero Crater. And what we know about this area, at least from orbit, is that it has a composition similar to that of volcanic basalt. And so for a long time, scientists have thought that this could be a lava flow that we've landed on. But more recently, especially with experience with Curiosity, which has seen almost exclusively sedimentary rocks, we've started to re-examine that assumption about whether everything we're seeing with a basaltic composition is actually lava. And so this is the big question for us. Are we looking at volcanic or sedimentary rocks? And those are the two, I think, dominant hypotheses that are out there right now. And Perseverance has the payload to help us figure this out. And so we can't wait to use our instruments, because really you have to look at the fine detail and texture in the rocks to make that distinction. And we've learned that from previous Mars rover missions. And so with the fractured unit that we have, what we know from orbit is that it has a mineral called olivine. And that's a mineral that's very interesting to us. And thoughts are that this could be an explosive ash deposit deposited into Jezero. On the other hand, we are in an ancient lake basin, and these could be lake sediments that we're seeing. And so in order to figure this out, we really need to get our cameras turned on. We need to take images of the rocks, and we need to get compositions back to learn more about those two things together to figure out what the depositional interpretation of these rocks might be. So those are really the big questions that I think we have right now, and those are hypotheses we've developed from orbit, and we're looking to test those on the ground. In terms of where we are in Mars history right now, we think that Jezero Crater is about 3.8 to 3.9 billion years old. And so the deposits within the crater are a little bit younger than that. We don't have a great constraint on the early or young side, but I think we can probably say that these rocks are between 3.8 to 3.6 or 7 billion years old. And that's where we're sitting here. So this is the time in Mars history when water was stable on the surface of Mars, and we think this area would have been a habitable environment. And so as soon as we nail down that depositional interpretation, we can really start to evaluate the habitability of the rocks that we have in front of us.
Okay, I want to take a social media question next. This comes from 10-year-old Zen, who's watching the stream on YouTube. And he wanted to know if weather on Mars would affect the samples that are taken. So Katie, I guess that's for you.
Yes, well, we have a weather station on the rover. It's called the META instrument, and this measures things like pressure, temperature, wind speed, humidity. But really, that investigation is on the rover for the purposes of preparing for future human exploration and letting us know what the modern Martian environment is and what Mars is like today. We're not too concerned about weather on Mars affecting the samples themselves because we're drilling rock and soil samples. So we're primarily interested in what's on the ground here rather than what's in the atmosphere when it comes to the samples. So we're not too worried about that. But we do have the ability to track things like dust storms, and we can keep an eye on that. And there's a possibility that with each sample we get, we may get a little sample of the atmosphere within each of the sample tubes. And so we'll be interested to find out what that's like. And so it's not a huge concern for us, but of course it is something that we monitor daily. And so we're very interested in knowing what the weather is like on Mars every day.
All right, we're going to go back to the phone lines, and next up is Lisa Grossman with Science News. Go ahead.
Hi, thanks for taking my question. This is really exciting. I have a question for Katie that kind of echoes Sarah's question. I want to know more about those porous-looking rocks that are right near the wheel. Do you have any ideas about specifically what those look like? Do they remind you of anything you've seen on Mars before, or are they something totally new? And then I have a follow-up question if we have time after that.
Okay. Yeah, sure. So there are a couple things that we've looked at and thought about already with these rocks. And of course, these are just our first impressions. And so we have many more observations we need to make about these. But when we think about these holes or vugs that we see in the rock, and depending on a sedimentary or volcanic interpretation, these holes or vugs can mean different things. And so having holes like this in a volcanic rock is not uncommon. As a lava solidifies into an actual basaltic rock, gases in that lava can outgas, and that is often what can create holes like that in the rocks, and we call those vesicles. And so it could be, if these are volcanic rocks, that might be what we're seeing. But we also know that in sedimentary rocks, holes like this can form when fluids moving through the rocks actually dissolve some of those rocks away, leaving behind these holes or gaps in the rocks. And so it could be that that's what we're looking at. And so I think really we have to get our instruments out and look at these textures in fine detail to really help us make that determination. And depending on what the origin of these rocks is, these holes can mean different things. And so we're excited to follow up on that and find out really what's going on here.
All right, thank you.
Oh, did you have a follow-up question you mentioned?
Yes, if this is a volcanic depositional environment, what does that mean for habitability? Does that mean that it was not habitable the way that you were hoping it would be, or could it still have been?
Yes, well, yep, absolutely. So one of the reasons why we chose Jezero Crater as the landing site was one, of course, because it has the delta and the lake sediments, and those are really the prime target for astrobiology and habitability. But we were also looking for a landing site that had a diversity of rock types and represented a diversity of lithologic or geologic processes to learn more about Mars's history and its evolution as a planet. And one of the main goals of Mars sample return is actually to absolutely age date these rocks. Geologic time on Mars is still very relative, and that's something we'd like to really nail down. And so volcanic rocks are really great to get absolute age dates from. So if these are volcanic rocks, we are incredibly excited about that from a Mars sample return perspective, because we can really nail that age date with a sample from a volcanic rock. We know for sure, absolutely, that there are sedimentary rocks in Jezero Crater that were likely habitable, and so we're not too worried about that. So if this turns out to be a volcanic rock, that's incredibly exciting for us, and we get to make progress on the diversity aspect of putting together a diverse sample cache.
Awesome, thank you.
All right, one more social media question. I know we don't have a helicopter team member up on stage with us here, but I'm hoping someone might be able to answer, because everyone's interested in ingenuity as well. Chris on Facebook asks, how many sols until the helicopter flights, and does it have a camera and sensors to record the flight? Pauline, is that something you can take?
Yeah, I can take the number of sols. Yeah, and so I should caveat, right? Like, it depends a lot what happens on Mars, but I think the earliest we are estimating that we could begin helicopter flights specifically, because there's actually a series of things we have to do with the helicopter before it can even start flying. So if you're actually asking specifically about the helicopter flights, it won't be until about Sol 60, and maybe a little bit earlier if we're super fast. I just want to emphasize kind of the journey that we would have to get there. So like we mentioned, we're going to transition to our surface flight software. We're going to finish a series of other checkouts on our new surface flight software. Once that's done, then the next thing we're going to do is we're going to drive to the next location, and we actually want to find a habitable environment for the helicopter to fly in. We call it the helipad location. So we don't know how many sols it's going to take. However, based on what we're landing, we're already starting to look at that data. There might be some really good, what we call helipad locations nearby for us to find. So it might not actually take us very long to drive there, but that's still work to go to figure that out. And that's why there's a lot of uncertainty. And I was going to mention about the weather observations that the 10-year-old on the social media was asking. It doesn't really affect the samples, and Katie was absolutely right about that. I was just going to add that the helicopter team's highly interested in the weather data not only for their helicopter flights, but also before we do their drop. Right now, they're attached beneath the rover, as hopefully everyone knows, and we actually have to do what we call the helicopter deployment, where we drop them off and then we drive away. And so that's a highly critical event, first time on Mars, and we're putting all hands on deck on that one and doing several practice sessions and everything. So that one we are, looking at the weather data actively for the drop-off and also for the flights. So, and then Adam, why don't you talk to the helicopter capabilities?
Yes, the helicopter does have the capacity to take color images and even color video, and beam that back to the rover, and then the rover back to Earth. That's part of the extra data that it can take. Again, we're bandwidth limited, so the first stuff that will come down from the helicopter will be engineering data.
And I understand, Adam, that the rover can take images of the helicopter.
Yes, of course.
Which might be the best of all.
Yes, but both. The rover certainly will be imaging the helicopter as the helicopter spools up its rotors, does its checkout. We'll actually have some video of that available to us. And then we will we'll watch, do our best to watch from the rover the helicopter's flights. And then the helicopter itself also has the cameras mentioned.
Okay. Moving back to the phone line, we'll go to Jackie Goddard of Times of London.
Hello, congratulations on those pictures. My question's for Adam. I don't know how you got through your intro to that rover landing picture there so calmly, because it's epic. Certainly gave me chills. So many people kind of just carried on with their lives yesterday, unaware of what is going on Mars. And I wonder, how do you explain to people the sheer significance and awesomeness of that picture and this landing, and what you're going to be getting up to on Mars? Thank you.
Well, thank you for the question. You know, I mentioned earlier that these things are hard. There's no doubt about that. It takes hundreds, thousands of people, years of effort. And insofar as it is that difficult, it represents a huge human lift to make this happen. So that image and the details therein really pull us humans here on Earth into the result of all of that hard work. You are brought into the surface of Mars. You're sitting there, 7 meters off the surface of the rover, looking down. I mean, I don't know if you can see this. I can. The plumes are hitting the surface of Mars, kicking up little wisps of dust. You can see on the upper right of the upper left of the image and the lower right of the image, you can see these little dust plumes in that on the surface of Mars, kicked up by our engines. So it's exhilarating. It is absolutely exhilarating, and it is evocative of those other images from our experience as human beings moving out into our solar system. Those images that bring us into the process of our exploration. And I'm so happy that we can contribute another to that collection.
Thank you.
Okay, we're going to go next to Irene Klotz with Aviation Week.
Thanks very much. I have 2 questions. The first for Adam. How much more mass could this EDL system accommodate? Is it at its max now?
So it's an interesting question. That's a question spacecraft designers have been asking for years. And unfortunately for the EDL system designers, the answer is fairly elastic. There's always a little bit more to give. We worry a little bit about being frogs in hot water and not noticing our proteins denaturing, that the water's getting too hot for us. But there is, in our EDL system here, probably some more room to be given. And with the next expeditions, we will always be carefully monitoring the risks we take on as we look to expand the performance of our entry, descent, and landing systems.
Thanks, and I'm not sure who would be best to answer this question, but I was curious how the selection of the helipad will be made. Is that going to be primarily with mass cam images once that system's operational, or what other tools are available to make that call?
Most of it will actually be using the engineering camera data. So that will be sufficient to determine the helipad imaging. And so once we get the stereo data, as we say it, we actually have some team members on the helicopter team that will be looking at that data and looking for the right helipads. And they'll be working together with science so that we can come up with a common path between science and helicopter to arrive at the right parking lot location. And once we get there, we're actually going to drive the rover around and kind of take a series of high-res stereo imaging all around and then do another assessment. So then that's mostly with engineering cameras. But we will absolutely do, high-res mass cam imaging too. But really what we just need to make the assessment is the engineering camera data. So.
Thanks. And what's the earliest that the rover would make its first drive?
I missed the beginning part.
What's the earliest? How many days before the rover, at the earliest, would drive?
So we're anticipating right now the earliest the rover would drive is, if I remember correctly, it was be Sol 8 or 9. I think it's Sol 9, if I remember correctly, is our current best estimate. And keep in mind that probably the first drive will be maybe a short drive just to check everything out, and then we'll do a longer drive after that. But in the meantime, we're also going to be trying to figure out the route and direction we need to go. So.
Thanks very much.
Okay, next on the phone lines, we have Tony Cabrera with ABC7. Go ahead.
Yeah, my question's about the celebration last night, with just how incredible, exhilarating you all described it. You said the team went wild, but how about once everybody got home? Was there champagne with loved ones? I mean, could you sleep? Were you just on your phone looking at everything? What was that like?
Well, maybe we should go. I'd love us to go and get everybody on here, because every team member, especially in this COVID time, has kind of a different experience of the celebration. I can tell you that we had a chief engineer's happy hour at 5:30 p.m. last evening, and that is, as it has been since the time of COVID, a virtual event via Zoom. And we had a huge collection of the team that was not currently working issues on the surface present, but we were all in our homes individually, and speaking to one another over the internet.
Yeah, and I can, just to add on to that, I can also say that there was a socially distanced consumption of ice cream outdoors shortly after the landing with some of the members of the team. You know, after we dispersed and went to our own homes, I'm sure a lot of us had a chance to sleep better than we have in recent past.
Yeah, and for the surface team, you know, it actually is just beginning for us. So on some level, we landed, and then we basically was, you know, game on for us, actually. So a lot of us were working well into the evening. I think most of us were there around till at least 10 p.m. last night, you know, and it was exhilarating because we were getting all this great data and seeing all this amazing details. And I would add for that, the surface team, you know, half the team is remote and half the team is present at JPL. So, you know, we're also constantly contacting our counterparts that are remote and showing them the images that we're seeing, what we call, you know, via our WebEx screens. And I think, you know, for me personally, I went home and just passed out from just the excitement of the day. It was a very long day for surface yesterday, and we've been telling the team to make sure to get their rest because it's just beginning for us, and to make sure they get their rest time. But I imagine in the coming days, I'll definitely be having a glass of wine in celebration for everything. So
yeah, as Pauline had mentioned, some of us are remote. So our image and data processing team is fully remote right now, working from their houses, mostly in Los Angeles, some out of state. And it was super exciting because, again, when we land, image team, this is our time to shine. This is now we're on for the next however many hours. And, you know, the next 5 days, we're working 2 shifts a day, almost about 20 hours a day. So when we had our first shift yesterday, everybody who was supposed to be working overnight, of course, wanted to be involved and was so excited to see these first images come down throughout and late into the night, hoping that they would then get a nap before then they're on as they continued to do their image and data processing over the evening. It is kind of a really cool thing to actually be on a WebEx with everybody's video on and during these COVID times, because, you know, typically we're having to spread out, but it felt like we were all kind of there in a way, and we really made the best of it. And it was a really cool celebration with everybody being able to share the images as they were coming down live through the evening. So it was really incredible.
Yeah, and for us in the science team, our entire science team is remote, and we have scientists ranging from Australia to Europe. And so everyone is on a different time zone. Some people were just getting ready to go to bed. Other people were waking up. And that's kind of business as usual for a science team working on a Mars rover. And so we, as Pauline and Hallie have said, we had to get to work. And so many of us scientists followed along with the first planning cycle for Perseverance. And we had our very first post-landing science discussion. And this felt like such a big moment for us. We've been meeting together as a science team for years and dreaming about our post-landing activities. And here we were on the surface with the rover, having our first discussion about science on the surface of Mars with real images. And so it was a great feeling, and we are going to continue that for many days to come.
Okay, we're going to go a bit into lightning round now because we only have about 5 minutes left. We do have to end this briefing right at 11. So we're going to take a few questions here. And if we don't get to your question, please call the Media Relations Office at JPL, and we'll ask if you guys can stay after a little bit. We'll do those questions by phone. But next up, we'll go to Amina Khan with the LA Times.
Hi, Hi, thank you so much for taking my call. Katie, on that point, it would be great to be a virtual fly on the wall in these science discussions. And I know there's so many different scientists, hundreds with different goals and different favorite targets. What are some of the, I guess I would call them friendly arguments happening among science team members about which target they should go to first and why? What are some of the compelling and competing arguments they're making for their targets of choice?
Yes, well, we've only just started this process, and really we got these first images done last night, and so the discussions are just beginning. And this is a period of time which is really great because I think the scientists feel very free to share their first thoughts and interpretations. And so, people throw out some wild guesses, and that is great, and that's exactly what we need to be doing as we're trying to figure out what it is we're looking at. And what the science team will transition while the rover is updating its flight software, which Pauline was mentioning. The science team is going to have a special meeting to talk about some of these things for the first time and say, okay, where is our next location that we want to drive to when the rover is checked out? And what is that location where we want to dig in and really use the rover's instruments? And so the science team is about to engage in that conversation. And we haven't had it yet. But we'll have it in the next couple of days with the idea that in about a week or so, we'll have consensus on where we want the rover to drive and what direction we want it to drive in. And so, of course, everyone, as you say, everyone has their own opinions and own perspectives, and it's really great to get those out into the forum of the science team. But many of us have done this before, and somehow we're able to get a 450-person science team in the same direction. And so that's one of our tasks that we have in the coming week.
Are there any examples of prime targets that, I know it's still early, but are there anything that have struck your fancy?
Well, yes. So as I mentioned, we landed right next to this very important geologic contact. And so I think one of the first decisions that the science team is going to have to make is where along this contact do we think we'll have the best exposure of rocks to make our first really detailed investigations. And so we'll be looking closely at the orbiter images and the images we have on the ground to try to identify that location along this contact.
Thank you so much.
All right. I want to thank everyone who came here today to give us taking the time away. And I know some of you on Mars time and crazy schedules. Thank you for being with us. We do need to wrap right now. If we didn't get to your question, we apologize, but please do call our office and we will get you set up to do a phone interview.